All right.
Okay.
All right, it's 12 o'clock. So welcome to this week's Iowa Learning Farms Conservation Webinar. I'm Matt Helmers at Iowa State. Have the great fortune to moderate today. And with us today, we have Dr. Matt Stephenson. Matt is a research data manager at Iowa State University, and he's going to talk to us about some of the work that he's been involved with on prairie strips. And so prairie strips support migrating monarchs and breeding birds. As always, if you have questions, please type those in the chat box and we'll get those to Dr. Stephenson at the end of the talk. But with that, Matt, the virtual floor is all yours.
Thanks, Matt. As Matt said, I'm a research data manager at the Bioeconomy Institute at Iowa State. Most of what I'm going to be presenting today is from my graduate work with the Prairie Strips team, working with Lisa Schulte-Moore. Insects are in trouble. This recent synthesis paper by Wagner showed that insect biomass has declined up to 75% in some areas, with annual declines of 1 to 2%. Butterfly monitoring programs have shown population declines of 30 to 50%. And at the end of it, they estimate that over 40% of insect species globally are threatened with extinction. It is also not a rosy outlook for birds in North America. So the Rosenberg 2019 paper estimated that almost 3 billion birds are gone compared to 1970s population levels. And grassland birds in particular have been really hard hit with a 53% population decline in the last 50 years or so. A lot of this in our region is due to just habitat loss. So Iowa was around 80% tallgrass prairie at the time of settlement, and the soil under those prairies was and is really good for growing crops. So the state was systematically altered over the next 150 years and is now majority row crop with maybe 5% grass cover remaining, but that grass cover has been planted back into areas that have been plowed so that only about 0.1% of the native tallgrass prairie remains. Most of that's in little tiny patches. So this is not great if you are an organism adapted to live in the tallgrass prairie and you find yourself surrounded by row crops, and it also has some serious repercussions for water quality in the region. So because most of the land in Iowa and the Midwest is privately owned, any kind of large-scale wildlife conservation effort is going to require partnership with private landowners. And indeed, farm bill type conservation programs dictate the design and management of millions of acres of privately owned habitat. So they represent an opportunity to optimize their design to improve the quality of habitat over large regions. So enter prairie strips. So this is an idea born at Iowa State and studied extensively here and elsewhere by partner organizations. It's this idea of using diverse native perennial species as a conservation practice, either planted on the contour or at field edges. The early research had very promising results, and it was adopted in the 2019 Farm Bill as Conservation Practice 43, prairie strips. And in the CRP implementation, it doesn't have to be on the contour. It can be on field edges, as I said. A lot of farmers like to use this as like pivot corners or just kind of in areas of low yield or whatever. This is some examples of implementations. So these examples were mostly planted before CP43 was developed, but they would fit under the implementation rules. And as you can see, these tend to be pretty narrow patches of habitat, and they're surrounded by row crops, which can be inhospitable to some species. And so if we are going to promote these as wildlife habitat, we need to know, are they actually quality wildlife habitat? You know, animals can live there, but do they do well? So before we proceed further, we need a couple of definitions. So for habitat quality, we're going to call this the resources and ecological constraints that govern fitness. And fitness is both adult survival and their ability to reproduce. And we're going to say that habitat is of sufficient quality if a patch serves as a population source rather than a sink. So a source produces more individuals than die in that area. A sink is an area where survival is low and animals come in from outside, but the patch never produces enough to replace them. And prairie strips vary in a couple of ways from how conservation practices have been designed in the past. But for today, we're going to focus on vegetation diversity as sort of the defining characteristic of a prairie strip, and also some discussion of the configuration of the strips. So let's start with insects. So I'm going to be presenting results on some monarch research. This was Caroline Murray's master's research that I kind of got involved with later. Caroline went out and counted milkweed stems in prairie strips and also comparison sites that were low diversity vegetation. Some of these were ditches or grass waterways or maybe a low diversity strip planted on the contour. So she counted milkweed stems in each treatment type, also counted the number of flowers there were, searched individual milkweed plants for eggs and larvae to look at reproduction, and conducted some transect surveys looking for adult monarchs. So we're going to kind of step through the major results here. So we have got swamp milkweed, common milkweed, and butterfly milkweed. And you can see that most of the stems of milkweed were common milkweed. The yellow triangles are prairie strips, and the red squares are lower diversity conservation practices. And you can see the lower diversity areas had much higher counts of milkweed stems. So common milkweed competes really well with brome monoculture. So brome kind of crowds out a lot of weedy species, but common milkweed is one that that will do all right in some of those areas. And I think just the ability to compete against a monoculture, but maybe doesn't compete as well in a really diverse polyculture is why the count of milkweeds was higher in the lower diversity areas. Looking at available nectar resources for adults to feed on, the prairie strips had higher diversity of floral resources. So just like you and me, insects need a variety of food sources in order to stay healthy. If they feed, you know, sort of solely from one or two species, they may not be getting all of the nutrition that they need. And you can see that across the season, prairie strips had more different kinds of plants blooming. They also had just higher densities of blooms. So with a little overlap early in the season, and then later in the season, particularly late in the season, prairie strips provided more food for adult monarchs. And the adults themselves were more commonly seen in the prairie strips. Again, a little overlap in the middle of the season, but generally speaking, higher densities of adults in the prairie strips compared to the low diversity practices. Caroline did not find a large enough number of eggs and larvae to make strong statements about reproduction in these areas. That could be because there weren't many, or it could be because they're teeny tiny little eggs and they're hard to find. But for whatever reason, her study didn't have a real firm statement on sort of the reproductive value for monarchs. So when we talk about insects and prairie strips, the first question that gets asked is, yeah, but what about the pesticide environment? So this is an excellent question. Pesticides are an important tool for managing crop ground. And we know that pesticides don't necessarily stay right where you put them. So a handful of prairie strip studies have looked at this and found that indeed neonicotinoids are water soluble, and they travel from their intended application area through the soil, are found in the soil and in the plant's pollen and nectar of prairie strips. And the concentration of the pesticide gets diluted along that pathway. So there is more pesticide in the soil than in the stems, than in the nectar. So far, it seems like the concentrations being found in the prairie strips are low enough to not be a concern. So Mara Hall's 2022 study estimated that the insecticide concentrations were between 10 and 130 times lower than the chronic LC10 for monarch caterpillars. And sort of more anecdotally, a number of strips researchers have kept honeybee hives in prairie strips areas for a series of studies, and they haven't experienced any colony deaths over those years. If you're interested in this topic, Amy Toth has a new publication coming out, should be in the next month or so, synthesizing all of the pollinator research that's been done on prairie strips, and shows that generally speaking, prairie strips enhance pollinator forage, both quantity and quality. They support more diverse and abundant wild bee communities. As we talked about, they do sustain adult monarchs, at least. They increase the productivity of managed honeybees. And although there is pesticide in the environment and insects do get exposed to it, so far it seems that concentrations are below the levels of negative impact. So that's the butterflies. Let's talk about the birds. So this is some of my graduate research conducted with Jordan Geese, a fellow graduate student in Lisa Schulte-Moore's lab. So Jordan's question started with, are there birds on the landscape? What are they? How many of them are there? So he conducted point counts for birds in fields that had prairie strips and those that did not. So in this field, this broad strip down the middle is a prairie strip. And each of these circles is a place where he would stand and count birds for a period of time. The control fields typically had very little in the way of perennial vegetation. Sometimes they might have some waterways, but this is a comparison of sort of no or few conservation practices to prairie strips. Jordan found that when you add prairie into crop fields, you get more birds. This is not super unexpected, but this is one of those things that you do need to look at. You might, you never know when you might be surprised. But we've got fields that have prairie strips in the teal color, and fields that do not have prairie strips are dominated by crops in the reddish orange color here. And looking at all birds combined, prairie strips had almost twice as many birds in them. If you look at only the grassland nesting bird species, that difference is greater. And then he broke it down by the most common species encountered. So red-winged blackbirds, dickcissels, common yellowthroats, and eastern and western meadowlarks all had higher densities of singing males in fields with prairie strips compared to those without. Jordan also found an effect over time. So many of our field sites, we began surveying them the first year that they were planted. And Jordan found that right away, even in the first year when the prairie strips are either very weedy or they're being mowed, there were more birds in the fields with strips than those without. And that effect increased over time for the first several years until it sort of levels out with the mature prairie strip. So you get a benefit immediately, and that increases through time up to some level. Okay, so we have demonstrated that the birds will come and use areas that have prairie strips in them. And then my part of the study was how well do they reproduce in those areas? So to answer that question, we have to go find a whole bunch of bird nests. I did this on 9 commercial farms and 2 prairies. So this is largely the same properties that Jordan used. We had a number of search plots, those are our little boxes here, in a number of different kinds of conservation practices. And we did a double observer search so that we could not only count the nests that we found, but also estimate how many nests we didn't find. And then all of the nests we found, we followed through time until they either succeeded or failed. And that's true for nests found anywhere on farms, not those just in the search plots. So I got a lot of results here. We're gonna just sort of step through it one at a time. So this is one response variable, plant species richness. So this is just the count of species in the search plot, going from 0 to over 60. And this is for 3 groups of birds. So dickcissels were about 25% of the nests that we found. Red-winged blackbirds were about 50% of the nests that we found. And then we also analyzed all grassland nesting birds as a group. And this includes the other 25% of our sample size, which was composed of about 21 additional species. So you can see that plant species richness was a significant predictor of nest density for dickcissels and all grassland nesting birds together. So on the left side here, you would have like a monoculture situation, like a contour strip planted to just smooth brome grass. When you compare that to a really diverse prairie area, for grassland nesting birds as a group, there was more than 7 times as many nests in the high diversity areas, and a similar effect size for dickcissels. For red-winged blackbirds, there was no statistical difference. I said we were also going to look a little bit at configuration, and in this case, that is the width of the patch. You know, how wide is the prairie strip or contour strip or terrace or whatever. And this was a significant predictor of nest density for dickcissels and grassland nesting birds. And you can see that there is some crowding going on. So the very narrowest features. So the narrowest conservation practice that we surveyed were terraces, but also, you know, contour strips and many designs of prairie strips would be on the low end here. And then on the high end, we've got 2 reference prairies that were around 200 acres in size, and those were our widest patches. So for grassland nesting passerines as a group, there were about 3.5 times fewer birds per unit area in those really wide patches compared to the narrow patches. And we'll come back to this again later. Again, red-winged blackbirds didn't particularly care about the width. They mostly cared about how close it was to water. That was the dominant variable for red-winged blackbirds. So we looked at nest density by variable, and then we also predicted what that means for several kinds of conservation practices that we studied. So again, in the green, we have all grassland nesting passerines as a group. This is split on the right into some prairie conservation practices, and on the left, low diversity grass practices. So as far as density goes, for grassland nesting passerines, for red-winged blackbirds, and for dickcissels, there were not large differences between the prairie practices and the low diversity grassland practices. There are some differences in here that are mostly down to the width of the practice and how close it was to water. So again, remember that 50% of the grassland nesting passerine sample size here is red-winged blackbirds, so their preferences have a strong effect on this group. So that was our finding for nest densities. So we know that the adult birds are there. We know that they are nesting. Now we need to know how successful they are at nesting. So we're going to start with plant species richness again here for dickcissels, red-winged blackbirds, grassland nesting passerines. There's a caveat for this one though. So because we began our monitoring of several of these areas in the establishment year, several of our sites needed mowing for 2 to 3 years. And so if you're familiar with best practices related to mowing and grassland nesting birds, you know that you're not supposed to mow an area of habitat until after the birds are done nesting, and that's for a good reason. So in areas that were not mowed, that's the solid line, nests survived better in higher diversity areas for red-winged blackbirds and grassland nesting passerines. So in a monoculture situation, compared to an area with more than 40 species, a nest was maybe 5 to 6 times as likely to survive to fledge compared to the monoculture area. But that was only in areas where there was no mowing. If an area was mowed, it was very bad to be in a high diversity area. So this has to do with the distance off of the ground that the bird is able to build their nest. In the low diversity areas that are dominated by smooth brome grass, brome is not structurally useful for building an above ground nest. And so the nest just kind of mostly sits on the ground, low enough that the mower will pass over it. If you're in a high diversity area, there's lots of structural diversity in the plants, and the birds tend to build their nests higher up, and they get whacked when the mower goes over them. So, you know, establishment mowing is generally considered a best practice for prairies, but just know that for the first couple of years, that is going to be detrimental to nest success. But we'll have to think of it as an investment in future habitat quality, because once you stop mowing it, it becomes way better. Looking at configuration again here, practice width was not a significant predictor of nest success. So even though there were way more nests in these really narrow areas, they didn't survive statistically differently than the wide areas. When you look at nest success by conservation practice. So again, here we got the prairie practices on the right and the low diversity practices on the left. You can see that generally speaking, the prairie practices have higher survival than the lower diversity practices. And if you compare, so prairie contour strips, the low diversity contour strips, much higher survival in the prairie practice. But then among prairie practices, the two narrower practices, contour strips and filter strips, did not have a significant difference in survival to the large patches. And that pattern repeated for our different subgroups as well. So at the beginning, we said we wanted to know if patches were population, sources, or sinks. Being able to definitively state if habitat is a source or a sink needs a whole lot of data. So in addition to what we collected, this determination needs both fledgling and adult survival. So we stopped following nests at the time the fledglings left the nest. And to get that, you need to use radio or GPS telemetry for relatively few birds, but those pieces of equipment are expensive, or you have to put leg bands on thousands of birds. Because of this expense, very few studies do that. Most compare to a benchmark rate of some sort instead. For our study, we selected a couple of reference prairies, which we thought looked like high quality habitat. And when we compare the prairie strips to those reference habitats, the prairie strips do just as well for nest survival. However, this relies on our expert opinion that these habitats are high quality. And if that is not true, then it reopens the question of whether or not prairie strips are sources or sinks. So to the best of our knowledge, at minimum, prairie strips are safer than the lower diversity linear practices. So if a landowner has a choice between putting in a brome strip or a prairie strips are definitely better as far as this study is concerned. And so are an improvement of habitat on the landscape. Whether or not the entire landscape is good enough is sort of a bigger question. To get at that, we looked at patch sizes of grasslands in Iowa. So each one of these lines is the probability of a pixel of grassland falling inside of a certain size of patch. And each line is about 8 acres. So you can see about 15% of the grassland in Iowa is found in a patch size of 8 acres or smaller. For reference, 8 acres is what you would get if you took a square section and put a 16.5-foot ditch in it and no other grass. That would be one grass patch of 8 acres. And this is what most of the birds in Iowa have available. There are a few larger preserves scattered throughout the state, but individual birds are really unlikely to encounter these. They're going to find the small patches. So real quick for the takeaways for monarchs, the lower diversity linear patches had more common milkweed than prairie strips, but the prairie strips had more blooming flowers and more blooming species than the contour strips. Prairie strips had more adult monarchs than lower diversity areas, and the prairie strip pollen or plants pollen and nectar did contain pesticides, but the concentrations were orders of magnitude below the LC10 for the monarch larva. And we didn't find enough eggs or larvae to make comments on source sink dynamics for monarchs. For the grassland bird reproduction, plant diversity was an important positive predictor of both density and survival. Plant density was also an important positive predictor of nest density and survival. I kind of skipped over that in the interest of time. Nests that were in the prairie strips had survival rates similar to those in the larger prairies. The low diversity grass strip practices had low enough nest survival that they are at serious risk for being ecological traps. That is, the birds weren't choosing the higher quality habitat over, in preference to the lower quality habitat, which is one of the conditions needed for an ecological trap. And we weren't able to definitively say if prairie strips are population sinks, but at minimum, they are safer than what's there now and are an improvement on the landscape. An important caveat to this is we didn't find all grassland nesting species in our study areas. Some of them are sort of well known to require large areas. These are species like bobolinks or Henslow sparrows or grasshopper sparrows. And those species will still continue to need larger conservation practices to successfully reproduce. I'd like to thank the many undergraduate technicians which helped find all of these nests, and our many funders and partners. And this is for the entire Prairie Strips team, with a few called out there specifically for my research. And with that, I will hand it back over to Matt Helmers.
Okay, thanks, Matt. And get your questions in. We have some already, but we should have time to hit those. If you are on and are wanting to earn a CCA CEU, please email Elena Whitaker. Her email is alenaw@iastate.edu by 5 o'clock today. Include your name, the name you entered to watch the webinar, and your CCA number. We can go to the next slide. If you watch this webinar live and are willing to fill out a voluntary survey, we'd greatly appreciate it. A voluntary demographic survey. only one response is needed for all 2025 webinars. So if you've done it before this year, thanks so very much. If you're willing, you can scan that QR code or go to iowalearningfarms.org/survey. We'll go to the next slide. We're going to have Eric Henning that'll talk about hydrologic and crop production impacts of drainage district improvement. So important topic to think about on drainage districts. So okay, I think then that maybe one last slide, which is if you can find the archive of this webinar and other webinars on the Iowa Learning Farms webinars page, and it's also on YouTube. So with that, Matt, we have some questions that have come in. Let me get back to that. Okay. This person asks that they tend to find a lot of ants on common milkweed and rarely find eggs on those plants that have lots of ants. Do ants prey on milkweed eggs and small larvae?
All right, so this is the point at which I say I am not an entomologist. So my focus is on vertebrate wildlife. My barely informed sort of knowledge of that is it depends what kind of ant, but certainly there are many predator insect species in these environments as well. And there's been some study on this. Master student Andreas Vargas was looking at predaceous ground beetles, trying to see if there's overflow and maybe some benefit to preying on crop pest species. His master's thesis is published on that, but the peer-reviewed publication is still in development.
Have you done any, or do you know of any similar research on woody edge of field practices, hedgerows, windbreaks, shelter belts?
So some of the practices that we looked at had a substantial woody component. Okay. So our focus was on grasslands, but we had a number of older practices that had been in place for a long time and had some woody encroachment. In particular, the terraces tend to get really woody. They're very difficult to mow, and so if you don't get out there with loppers or a chainsaw or something, they tend to get overgrown. We found a small negative effect of woody vegetation for like some analysis groups, but it wasn't a major component. This is probably due to sort of the somewhat generalist nature of our response species. So red-winged blackbirds and dickcissels are not super picky about where they build their nest. Some of those other species I mentioned, like bobolinks or Henslow sparrows, are known to, really avoid woody vegetation. So they're avoiding the patches because they're small anyway, but they might also not appreciate the woody component.
Okay. This person commented, it was nice to see that neonics were not in problematic levels in plants in the prairie strips. Were any other pesticide classes examined? They were wondering specifically on fungicides since their use has increased pretty dramatically.
Okay. I believe the answer to that is no. So these studies here at the bottom, I'm going to direct you there. I think this captures most of the work on insecticides to date. I'm not certain about the fungicides, but I think most of the research focus here was on neonicotinoids.
Okay. All right. We got. Okay. This might be a little bit outside of your area, but when establishing prairie and prairie strips, what are suggestions for suppressing the brome? And if you're treating a large area, is there a chemical treatment you would recommend, and what's the impact on wildlife?
So yes, so I am not expert in the design or establishment of the prairie strips. I can give some general advice. So a lot of times when establishing prairie strips, farmers choose to follow a soybean year and plant into areas that were previously soybeans. So the herbicides used on soybeans are going to be really good at suppressing grass growth. And just previously cropped areas have a much shallower seed bank. There's not as many weedy seeds hanging out in those areas. If you are trying to rehabilitate an area with brome, it's a lot of work. Um, Fire at the appropriate time of year is going to be really important. Possibly also some targeted herbicide. I can't make a recommendation as to which.
All right, here are some that I think you can. What time of year and day did you count the bird nests?
Sure. So we collected data over 5 years, 2015 to 2019. Our field season was, broadly speaking, the summer semester. So from about the beginning of May to the middle of August. The most of the bird nests were initiated from like late May through the end of June. There's a couple species, so like American goldfinches in particular, nest later. They have to wait for the thistle to bloom before they start making their nests. So they were really just kind of ramping up at the end of July. But most of these species are nesting from like late May to the end of June.
Okay, that was somebody just asked kind of when they were done nesting, but they also had a additional question there that does grazing have the same negative effect as mowing if done too early?
I would have to check. So there's a lot of research on this area. My off the cuff impression is that no, grazing's not going to be anywhere near as detrimental, but
Okay.
it depends on the intensity of the grazing and a bunch of other things. So I'm gonna punt on that and say
Okay.
a lot of other folks have looked into that.
Okay. They this person indicated their prairie strips are now surrounded by diverse pasture of legumes and grasses to be used in rotational grazing. They're wondering what they might what they might see in bird activity for that as that patch size maybe starts increasing, even if it's not quite as diverse as their prairie strip.
Yeah. So anecdotally, some of those area sensitive species are not making their choice on where to set up their territory based on the diversity of the grass that they see. So it's really common to hear male grasshopper sparrows singing from a cereal rye cover crop in the spring. They look and all they see is a grassy area, and they don't know that it's one species and that it's not gonna be durable. I know that bobolinks will nest readily in pastures. So I think as far as like the area sensitive species go, as long as you don't have that, bare ground in the spring when the birds are setting up territories, that would probably be beneficial to attracting some of those species. Generally speaking, in landscape ecology, the softer the habitat edge you can make, the better. So, high diversity grass bordering low diversity grass is going to have fewer problems than high diversity grass bordering a road or bordering tilled ground.
Okay, I think you kind of answered this, but any nesting success from bird species that are in steep decline, grasshopper sparrow, Henslow sparrow, eastern meadowlark?
Yeah, so this is the conundrum, right? The species that we care sort of the most about, or at least where the need is most urgent, are the ones that are the hardest to find because there's fewer of them. So half of our sample was red-winged blackbirds. This is because red-winged blackbirds are pretty common and they're very easy to find their nests. When you get close to the nest, they fly up in the air and they scream at you and they say, "Hey, my nest is here." And then they
Even
peck
I
you.
could find one of those, I think, Matt.
Yeah, and then they peck you on the back of the head
Okay.
while you're working on it. That said, they are in decline along with the rest of the grassland bird suite. Dickcissels are a species of greatest conservation need in Iowa, so that's a sort of a state level designation of conservation need. But no, we didn't find enough nests of maybe sort of more nationally imperiled species. We did find a handful of grasshopper sparrow nests, but nothing that we could work with statistically. And there were adult Henslow sparrows and bobolinks singing at some of our properties, but we never found any nests.
Okay. This person was surprised that width was not a significant predictor of nesting success. Do you have any guesses as to why it was not significant? And what was the most significant factor in determining nesting success?
So for a full sort of a full
Oh,
treatment of everything we looked at, I'm gonna point you at a forthcoming publication. As far as the most important, we did compare effect sizes, and basically things shook out to either important or not important. There wasn't any effects that were clearly the most important, but there are factors that are easier or more difficult to manage, right? So our paper on this breaks it down by effect size, where you say that a one standard deviation change in the predictor variable results in an X-fold change in nest success. And it's easier to increase vegetation diversity by one standard deviation in a lot of situations than it is to increase prairie strip width by a standard deviation, or distance to water, right? Like those placement kind of factors may be more difficult to get just right than just sort of paying a small premium on your seed mix to get a higher diversity planting. So there wasn't anything that standed out as the best thing to do, but maybe there are some things that are the easiest thing to do.
all right. Matt, I think that gets at most of the questions that we had in there. Want to thank you so much for the excellent work and being willing to give the webinar today. It was great. Again, if somebody is wanting to earn a CCA CEU, please email Elena Whitaker at iastate.edu. And so her email is alenaw@iastate.edu. Please email her by 5 o'clock today with your name, the name you entered to watch the webinar, and your CCA number. And tune in next week to hear from Eric Henning. I hope everybody stays safe today with any potential weather. And thanks again, Matt.
Thanks, Matt.